Good afternoon, all of you. Myself, Teres Bemila, working as an assistant professor in Information Technology Department of Shanankar Kachi Engineering College, welcomes you all of you for day 6 session 2 of AICTE sponsored online refresher program on developing secure IoT applications. It's my great pleasure and honor to welcome our esteemed speaker, Mr. Jeetendra Shenoy. Sir is going to deliver today's session. Sir is working as an assistant architect in LTI. He has over 22 years of experience in the digital space. He has built and deployed large-scale application in the area of embedded and open system. Thank you so much, sir, for joining today's session. Sir is going to deliver the topic on roles of IoT in new digital age. Thank you so much, sir. Over to you,
Yeah,
sir.
thank you. Okay, I'd like to share my screen. Okay, what can you see now?
Sir, you are visible.
We are able to see the screen shared by Nita Jowre, madam, sir. Yes, you
Ah,
can start.
yeah, the topic is actually thank you everybody for attending this session, especially all the teachers and professors who are there. So what I'll do is I'll actually go through because already you have some sessions which are on IoT. So there will be some background which is already done by earlier speakers. So what I'll do is I'll actually try to weave, and if there are any questions, just feel free to ask those. Okay. So moving on to the next slide. So the agenda is like I have broken down into 4 parts. Okay, so we will understand what is the digital age, how it has come in. Okay, what are the major building blocks in the digital age, and how these building blocks are impacting the society. At the same time, how is IoT playing a major role in these building blocks, or how these building blocks are enabling IoT. Then what is the way forward and how it will impact our lives actually down the line. Okay. So if you look at the digital age, now it is an age of Aquarius. So if you look at the Aquarius sign, it is a man with a pitcher from which there is flowing water. Actually, in mythological terms, it is like not water, but it is electrons. So it depicts actually old gives way to new. Means there will be a radical transformation which will happen in the world. Okay. And you will see an exponential progress in digital areas like okay, I don't know how many of you must have gone in the bank in earlier days where you get a token and you withdraw some sum. Okay, and it is now totally self-service where you just take a piece of plastic and you convert it into currency. So it is like self-service. So nobody in those days must have thought that where the cashier is there, there are two managers who check your check, check your signature, and then pay you the cash. So all that will get replaced. Okay, so so like that, there are many examples where if you look back, okay, you must have never thought that this can happen. Okay, so these kinds of things will happen in future. Okay, so next we will look at some digital transformations in some areas like energy. So energy is a major area. So what do we mean by energy? So energy can be electricity uh, primarily because right now we are mostly dependent on electricity. Everything is driven by electricity. Other than that, it is black gold, which is nothing but oil. Okay, so down the line, slowly oil will its importance will slowly vanish out and most of the stuff will be driven by electricity. So how is electricity going to impact? So there will be smart grids. Now, what do we mean by smart grids? So right now, electricity is made by big boys and that is pushed down the line and it comes down to your socket and where you pay for whatever you use, right? later on it can be other way around also. You can produce your own renewable energy and that can be pumped up back to the grid. So the grids can be smart. Even the meterings can be smart. Okay, so we'll talk about metering. Uh, Now microgrids. So microgrids will be smaller grids, so which are not connected to the major grid. So they only tap into the major grid only when required. Now communication. In in communication, you must have seen that there is a major change, right? So from one room to another room, okay, people just don't walk over and talk. They just do WhatsApp or some chatting application, like whatever it is. Like here, in case it is Teams, in some case it might be Slack or some other tool, right? Then there are hologram based virtual calls. Then there are 3D imaging. There are multiple ways of communicating. So these things will change. Transportation. So transportation is another area where there will be a lot of change because in transportation, the cost is actually the fuel and how you optimize your movement of goods from one place to another. So this optimization will take place with integrated fleets, like which van is in which location, which ship is in which location, at what time it will berth, okay, how much time it will take to unload, when should the truck be ready on the port to pick up. Okay, so most of the things will be in JIT format, which is nothing but just in time. Finance. In finance, there is an overall impact. So if you look, in earlier days, you have a lot of currency notes, right? So nobody believed in actual plastic currency. Now it is all digital. So most of the places you will be using your credit cards, debit cards, or your NFCs, okay, contactless payments. Okay. Then there are cryptocurrencies, which are again totally digital. So like Bitcoin, which is the very hot or which is like very popular, but there are other cryptocurrencies. China is like pushing for their own cryptocurrency. Medical. In medical, there will be virtual medical assistants. Like earlier, whenever we used to get like sick, we used to go to a general practitioner and then he used to take the necessary actions. And then if it is something serious, he will write to an hospital and so on. So all that will become virtual. So it might be an actual person or it might be an actual bot which will be sitting on the other side with an AI, and depending on our symptoms, common symptoms, it can immediately ask for an remediation saying that okay, you need to take so and so medicines and ask the pharmacy to deliver those medicines in the dosage to your house. So it can be that integrated. Now, if you look at manufacturing, a lot of smart manufacturing will take place where assembly lines will be totally integrated, and you will see a lot of just in time stuff happening in manufacturing. Here major role will be played by 3D digital printers and so on, because that will help to make the models, and then once the model is there, you can actually do the mass manufacturing. So a digital twin can be created. So we'll talk about digital twin later on. Then if you look at agriculture, okay, agriculture will become more and more sophisticated. Okay, give me one sec. There is a pigeon which is creating that background noise. I'll just make sure it goes away. Hello, sorry for the interruption. Okay. Now, if you look at agriculture, so what will happen is if you know that soil is just a medium, plants just take nutrients from the soil. They don't require soil as such to build their building blocks. Their building blocks is actually carbon. So, and they take it from carbon dioxide, which is there from the air, and they take water as the main uh, other ingredient and use photosynthesis to do their stuff. So you will have a lot of farms which will be based on water-based aquaculture type of where you will have aquaponics and aquaculture which will be put together. Okay, now what do we mean by aquaculture and aquaponics? Okay, well, when we have fish in the water, we say aquaculture, and then we say aquaponics. It is like having fish along with the um, your whatever vegetation you are trying to grow. So, and it can be built into and closed loop cycles. So these kinds of integrations will happen. So you will have like lettuce farms which are totally integrated, tomato farms which are totally integrated. So there will be robots which will be doing work right from sowing till harvesting, and lot of technologies like optical recognition, then sensors sensing, okay, what is the actual temperature, what is the humidity, okay, taking care of irrigation and the nutrients. Okay, so those things will be highly integrated. Now if you look at education, okay, uh, if you look at Udemy or any of these education portals, they are big and lot of stuff is going virtual. Now why it is going virtual? Because when it is physical, the contact is to the participants who are only there in that room. But when it is virtual, the same content can be delivered to multiple people with multiple times. Okay. Now here comes an drawback where you say that the practical is not there, right? So even the practicals are taken forward in a virtual way. So we will look at what is AR, what is VR, and how it is impacting lives. Okay, and how it will impact major in education industry as well as in the gaming industry and the training industry. Okay. So now we'll move on to the next slide, which is like end user devices. Okay, so you must have seen in IoT other lectures like there are around 7 billion people on this planet, right? So according to Gartner, okay, like Gartner Foresters are the major guys who do lot of analysis and they bring out papers. Okay, they say there will be more than 20.8 billion devices. So roughly like for each person there is 3 to 6. Okay, some people might have one, but some might have six. But this is going to balloon up by 2030 to 50 billion devices. Okay, so now what are these devices? It can be any device. You have smartwatches, self-driving cars, then your television. Okay, your baby stroller might be also having devices which detects, okay, what is the location, okay, is the baby crying or whatever. Okay, so there are a lot of things can be made. Medical implants, those are the major new wave which is coming in medical field. Like you must have seen Abbott or other guys already advertising things, right, where your vitals or your heartbeat pulse, all this is captured in near real time and passed on to the actual center where it is crunched, and if there is any abnormality, okay, immediately alerts are sent and necessary actions can be taken. Okay. Now radio frequency identification, which you must have seen already in like if you go to a store, okay, and if you pick up some item, okay, and generally when you go to the cashier, he will take that and he'll remove that pin, or he will put it against an demagnetizer, okay, to remove that radio, because that there are two parts. Okay, there is a reader, okay, and a transmitter, right? So they will make to provide to make sure people don't steal goods, they put that. But this will play a major role in IoT area like radio frequency. Near field communications are like you have credit cards where you just tap, right, and automatically the credit is deducted. So those are near field communications. Uh, then sensors are something which will sense things and give you readings. Actuators are something which will actually do things in the field, means they will move items, they will do something. Okay, so those are actuators. So sensors and actuators will play a major role. Okay, then mobile phones. Okay, that will be a major device. Okay, most of the things will be controlled by your mobile phones. Right now, see your radio. Okay, your watch. Okay, all that is gone, right? Okay, it is on your mobile. Okay, your MP3 player. Okay, it is in your mobile. So you name it, your digital camera, it is in your mobile. So if you look at it, mobile will become an central piece. It will not be just an device where you will just take calls. Okay, so it will become a major device. Okay, down the line. Now, home appliances. Okay, the home appliances right now are disconnected, but down the line they will be all connected onto an grid inside the house, and they can interact with each other. Like they can interact with the energy grid, they can interact with the consumer grid, they can interact with the retail shop, and so on. So, like if you can. So what is in smart grids? Like what's going to happen is right now you pay a fixed charge, right, for the electricity per unit rate. Okay, when electricity is generated, okay, that is an amount of electricity which has to be consumed. If it is not consumed, it is an voltage difference. It just goes away. Means it is totally waste. You cannot say that, okay, I am generating X number of megawatts and only half of it is consumed by the people. So I'll get paid for only half, but the other half I'll store. It is not possible that way. Okay. So what will happen is they will optimize in such a way such that, okay, when the load is less, they will charge less. Okay. So they want more and more people to use electricity during those non-peak hours. Okay, so these devices, okay, will have intelligence where they will automatically detect such things, detect such events, and they will start during those periods. Okay, so those will happen. User will be able to interact with them in voice and all that other uh, formats. Okay. Now, if we look on to the next area, which will be storage. Okay, now all these things will require some things, like these are the things which it will require. Storage. Okay, storage will which will be required will be huge. Okay, so like one autonomous car. Okay, self-driving car will take around 4000 GB of data for every 8 hours of driving. Okay, now why it is so? Now, if you look at a car, it already has microcontrollers inside. Okay, so like if you take a Mercedes Benz or a Swift car, okay, we will take a normal Swift car. It has around 72 microcontrollers on it. Okay, some of them sit on the CAN bus. Okay, so CAN is one of the protocols. Okay, so you generally have an OBD port which is under your steering wheel where the car technician puts in some device and he gets some number, right? Okay, and that way he can tell the car's health and so on. Okay, so that's called an onboard diagnostic. Okay, so it taps into the CAN network. Now when you have autonomous cars, you will have sensors all over the place. Okay, front, back, left, right. Okay, to sense if somebody is coming in the middle, what is the rate at which the front car or the vehicle is moving? Is there a car which is blindsided or a vehicle which is blindsided and so on? So all this data will have to be actually integrated in the scan network where it will actually control your steering. It will control your acceleration, the braking mechanism, and all the car electronics inside. Okay, so there will be a huge amount of change which is going to happen in uh, the network which is present inside the car. Okay, now if we look at aircraft engines, okay, aircraft engines are one of the complex stuffs. Okay, which where lives are dependent on, like, so each engine generates around 50 gig of data in 1 hour flight. Okay, so that is generally like if you look at Boeing or any of these big companies who supply engines, they process these kinds of data in near real time to understand how the engines are behaving, because there are two kinds of maintenance. Okay, one is preventive and one is predictive maintenance. So we'll look at predictive maintenance down the line. Okay, now when you capture such amount of data, okay, the speeds are very important. Okay, so right now if you if we see, okay, I might have to, if my speeds are not good, okay, network speeds are not good, I might have to shut down my video, right? Okay. But if you are looking at something like 40 gig or 4000 gig of data, which is there, which has to be transferred, or 50 gig, which has to be transferred in 1 hour, okay, and not just one unit, okay, there will be multiple of these aircraft engines, and all of them are trying to pump data. Okay, so you can think about what is the capacity required, what is the bandwidth, what is the storage, and how much processing power will be required. Okay, so moving on to the next slide. Okay, computing. So near real-time processing of data and real-time processing of data. Now we have to understand what are the differences of both. Okay, now if a car is moving at 80 kilometers per hour, and if you want to take a turn, if you just turn the accelerator just before or after the right movement, then it is not going to stay in the lane. Okay, so it has to be real time, means the steering wheel, moving the steering wheel has to be taken at that instant. So if there are controllers which are having other threads running, means other processes running, okay, and taking care of other housekeeping work, they have to drop those and they have to jump onto this task because this is an high priority task. Okay, so there are technical problems like priority inversions and so on. Okay, priority inversion is one of the hot thing because in embedded that creates a lot of problems. It created problems in Mars rover, which NASA had sent on Mars. Now near real time is like you have video things which are coming in. Okay, you cannot have frames going out of order, right? But you need to have near real time. Okay, parallel processing because a lot of data is coming in and you have to process them and bring them together. So that's why parallel processing will be on. Okay, scale up and scale out. Okay, scale up is like you take this same box, you take one box and you put in more RAM, you put in more compute power. Okay, you try to beef up that same one unit. Okay, so that's not going to work in near future. Okay, so already people are going to scale out. Scale out means there will be multiple machines who will work in tandem or in like they will work together to carry out a task. Okay, so that's a scale out feature. Okay, energy requirements. Okay, so whenever you talk about some computing or anything, energy is the primary thing, and energy is like a very sacred resource. So you cannot have infinite amount of energy. Okay, we get infinite amount of energy from sun. Okay, but whatever energy sources we have other than sun, okay, those are finite. Okay, because we are tapping into like hydel power or some kind of power which is not infinite. Okay, even if you look at nuclear energy, okay, it is a finite amount of energy depending on the amount of fuel which you have. Okay, computing speed, crystal frequency. So if you look at hertz, okay, so you must have, so our life depends on the heartbeat, right? So same way computing depends on the crystal frequency. So you might have 8 megahertz or depending on what frequency that particular microcontroller works. So that will be compute speed. Okay, so processing bits. So that is the amount of data it can process per unit. Okay, so 8 bits, 16 bits. So you might have, if you look at Sigfox, you have only 12 bytes, right? Yeah, there was one session on Sigfox, right, where you can use Sigfox for transfer. Okay, so can you use 8 bit or 16 bit? So that is your choice. Okay, network. It has to be ubiquitous. Means what? Means it should be always present, available everywhere. Okay, because everything will start talking to each other. Okay, nothing will be isolated. Throughputs of the network will be very important. Okay, bandwidth. Okay, now what is difference between throughput and a bandwidth? Throughput is the rate at which it will transfer, and bandwidth is the amount. Okay, at per unit. So. you will see that throughputs are going exponential. Like you have gigabit Ethernet, right, which is going at 1000 Mbps. Okay. Now, can you increase it further? So newer and newer technologies will come in where they will want to increase the throughput with so many devices talking. It will be a huge amount of data. Okay. Even your voice call now is actually going on data. Okay. 4G is nothing but your voice doesn't have a channel. It gets converted into data packets and goes on the network. With 5G coming in, every pole on the road will get converted into small transmitter. Okay, like literally you will have so many different transmitters of 5G all over the place. Okay, now in order and out of order. Okay, so here we saw near real time and real time. So that will also play a major role in network packet ordering. Okay, so we'll move on to the next one. Security. So if you look at security, you had sessions, right, where you talked about security. So security is like it will have multiple layers now, right from your device layer to the top layer, right? So it will be like onion. So you will have, so if somebody attacks the last layer, the external layer, then he has to again peel the next layer. Again, he has to peel the next layer. Okay. So these things are there. So nowadays with the huge amount of computing power, suppose you have given a password, right? Okay. And if I write a system where it just takes the password and logs in, okay, I know the amount of keys which are there on the keyboard are fixed. Okay. I can make the number of permutations. Okay. And I can just brute force and I can detect your password. So there are ways where people can brute force things. So security is another area where it's an cat and a mouse race where okay hackers try to catch the people who make things secure, and people who make things secure they go on to the next step. So you will always have a lot of things coming into this area. Now if you look at RSA, okay, RSA is nothing but it is public and private keys. Okay, so we'll talk about RSA later if we had some time. Okay, um, then we'll have human factor. Okay, now what is human factor? Is like the key link in everything is the human factor. Okay, because humans, if they start sharing passwords or if they start sharing data, okay, nothing can be done. Okay, so the security is useless. The chain is strong as the weakest link, means in your whole security thing, suppose your router configurations are not proper. Okay, so whatever you do, okay, you can be hacked. So everything in this onion layer has to be strong enough. Now the man and the dog story. Okay, so this is like an paradox which will actually happen in future. Okay, so the whole manufacturing unit, okay, is automated. Okay, so it's completely automated. Okay, so it okay, so no human intervention is required. Okay, so why the dog is required then? The dog is required to make sure no humans, okay, go towards this unit. Okay, because it is self-sufficient and it can work on its own. Okay, but then why the man is required? Okay, the man is required to feed the dog. Okay, so that's how the whole thing will happen down the line. So things will get automated in uh, at this level where no human interaction will be required. Okay, embedded chips, POS terminal. Now, what are these embedded chips? Like, okay, now you must have seen a terminal where you swipe your credit card, right? Okay, so your data is encrypted on your card as well as in the chip. Suppose I open the POS terminal and I put in some extra units there so I can detect what is coming from your card. Okay, then the whole security is flawed, right? Okay, so there will be chips which which are chips, okay, which are moment you open, okay, they will be rendered useless. Okay, so if you think like your POS terminal, if you try to open it, the terminal will be useless. Okay, so those types of things will come into picture. Okay, now access to data will be key. What do you mean by access to data will be key? Now if you look at Google, okay, what does it do? Okay, how does it make money? Okay, it makes money on the amount of data it has captured, right? You leave footprints when you do Google search, right? It uses that and does AdWords. Okay, so through AdWords, Google is making a lot of money. Okay, and that's why it is giving you a lot of free service, right? If you go on Android phone, okay, uh, you will have location on, and if you are driving, it will automatically send that data to Google servers, and it can tell from bunch of users, okay, who are driving on a particular road, if their speeds are getting low between two particular transfers to the server, they saying, okay, he has moved, not moved much, okay, in last 5 minutes. Okay, that means there is a congestion, right? And we use Google Maps and try to see congestions, right? How does Google get this data? They get this data right from our devices. Okay, so whatever you do in the digital world, things will be captured. Okay, and people who have your data, okay, or whoever has the data will be the key. Okay, so we'll move on to the next slide. Okay, so if you look, the challenges will be like in near future, it will be uh, massive scale. So things will be like huge. If you look at Google data centers, they are huge. Okay, huge means like football field is nothing in front of their data centers. Okay, and they have multiple data centers. They have data centers under the sea also to reduce their energy consumption. Okay, they have data centers in snow peaks. Okay, where it is like snow is always there, and that's where they use their power, cooling power. Then if you look at their motherboards, okay, which they use for computes, you will not have any sound related chip or any of these chips which will be extra on the board, which can consume energy. Okay, so at that level, things will become uh, embedded oriented. Embedded means you make something which is fixed to do that job and nothing else, nothing more, nothing less. Okay, unparalleled speeds like compute speeds will be required. Okay, because we have seen some examples, right? Heterogeneity, like why heterogeneity? Okay, if you like most of us own cars, right? Okay, suppose the headlamp is broken, so you have to get an headlamp of, okay, or the bumper, okay, is dented. You have to get that headlamp from the dealer who has that same bumper. You cannot take a bumper from some other car from the same manufacturer and just attach it. So there is a lot of heterogeneity in the world. Okay, not just in protocols, it will be in every place. Okay, so even when we talk about integrating our devices which are in our home, okay, they will be on different protocols. So you have to have gateways which talk different protocols. You will have to handle things across different kinds of devices and so on. Then security is very important. We will see why security is important. And robustness means it should be very robust and reliable. Okay, means like it it works for some times and then it doesn't work for some time, then it is no good. Okay, so robust means like every time it should work. Okay, now security we will go in detail. Okay, after some time. Okay, so we'll move at key building blocks. Okay, so now why these are key building blocks? Okay, so here now IoT have put it on top, right? So because we are talking in terms of IoT. Okay, and already I think a lot of sessions have been done on IoT. Okay, so I'll not dwell too much into IoT. Okay, but I'll delve into other parts and how IoT plays roles, okay, into these things and how it will affect us in the future. Okay, so we have digital assistants. Okay, and now what is digital assistant? So we'll go in detail about that. Okay, cloud computing. Okay, so we'll go in detail. Analytics. Okay, big data. Okay, what is big data? Why it is required? Then blockchain, AI. Okay, digital twin. Okay, autonomous vehicles. Okay, autonomous vehicles are here to stay. Okay, now what do I mean that? Okay, so they will be like driverless vehicles. Okay, if you look at fleets, okay, fleets means you have trailers, right? Uh, in US, okay, there are huge trailers taking goods from one place to another. Okay, in India we also use rail system, but US is like the rail system is there, but most of their goods will be moved through trailers. Okay, there are a lot of drivers who move goods around. Okay, now those will become driverless, and there will be trains of these trailers. Okay, what do we mean by trains? Okay, these trailers will automatically connect to each other. Okay, means not physically. Okay, when one trailer is going and you have another trailer behind it. Okay, excuse me. Okay, another trailer, and it will just join the trail behind the main trailer. Okay, so you will see trains of trailers growing. Okay, and they will be automatically connecting. Now how does that help? Okay, it helps to save fuel because of aerodynamics. Okay, you must have seen birds flying, right? So they go in a particular shape, so all these things will come into picture. Okay, then there will be missiles, like we will talk in warfare. Okay, where um, you have, suppose you have, you see, we have bought Patriot missile, right? What is that? It shoots another missile, right, which is coming in. So there will be missiles which will split into parts. Okay, and it will go independently, and when it is near to the target, they will all come together and deliver the load. Okay, so these kinds of things will happen down the line, where individual parts will have intelligence to come together and become one. Okay, adaptive manufacturing and 3D printing. Okay, so, okay, when I meant vehicles, it is not just vehicles running on the road. So that's why I gave you an example of a missile. Okay. Now, next one was adaptive manufacturing and 3D printing. So this 3D printing will play a major role. Okay, we'll see how. Okay, robotics and automation. Okay, that will play AR, VR. Okay, we'll go in details of all this. Okay, so we'll move on to the next slide. Manufacturing. Okay, so key will be huge. JIT. Okay, what is JIT? Just in time manufacturing. Okay, you don't have to build big warehouses. You want to make sure the vehicle to pick up, the vehicle to deliver, the time to manufacture, all this is integrated across all your vendors, across all your machineries, across all your resources. Means your planning will be in such a way so that you know that you have three assembly lines. It takes so much time. Okay, to get this thing done, you have so much orders in the pipeline. Okay, and it takes so much time to deliver. So all this will be automated. Okay, there will be huge amount of AI built in with machine learning models. Okay, because the cost of manufacturing will have to be reduced. Shop floor monitoring. Now, when we look at shop floors, okay, some of them are assembly lines. Okay, now what do we mean by assembly lines? So if you look at a car manufacturing, okay, they will put the wheel, they will put the chassis, they will connect the wheel, then it will move on to the next phase where it will put the internal part, then the like the body frame, then they will put the top frame, then some robots will weld it. Okay, then it will go on moving, right? So it will spend some time on one uh, place, and then it will move to the next place, then it will move to the next place. So these are assembly lines. Okay, so these assembly lines are very, very important because uh, that's where your productivity is counted. Okay, so you want to make sure everything is running perfect. Now suppose you are doing a paint job. to get the paint job done, you have to make sure the paint room is at a particular humidity, at a particular temperature. Okay, so all this will be monitored in near real time and necessary actions will be taken. So sensors and actuators, okay, they will play a major role in this, not just robots which are doing the assembly, but overall, okay, things will get automated. AR VR. Now what AR VR is like, okay, now I'll explain what is AR and what is VR. Okay. AR is an augmented reality. Now what do we mean by augmented reality? Augmented is like you have something which is visible to you now. Okay. And on top of that, you are putting in some image. So suppose I am wearing a glass. Okay, and I am looking, okay, suppose I own a car and the car manufacturer has given me an AR application. So using that, okay, when I open the hood and if I wear the glass or if I use my mobile and look at the contents in the car under the hood, it will automatically tell me what is where. Okay, and it will superimpose on the image which I am seeing. Okay, and then it will tell me, suppose I want to change the oil. So I'll just say I want to change the oil. It'll immediately tell me what to do in which location. So it'll start showing me that you open the lid at this place, then do this, and it'll start guiding you. Okay, so those are AR stuff which will be very hot. Okay, so that down the line you will see a lot of AR stuff, like even if you go to retail shops you will find that. Okay, VR, now VR is totally virtual. Virtual means it is not there. Okay, when you see it, but you see it only in your glass or on your device. Okay, to give a mm, very simple example is like you have Google 3D, right? So like you can walk on the streets in some areas, right? Okay, so if you go open Google Map, okay, so there will be some locations where you can actually move your mouse and you as if you're seeing on this side, as if you're seeing on that side, right? Okay, so you can wear an Google Glass or any glass, and then you can feel as if you are going into that particular or walking into that particular alley or that particular square or some historical location. Okay, now how VR will be important. Okay, we'll see that down the line. Okay, then automation. Okay, so automation we talked about. Transportation, connected fleets, bus tracking and optimization. Now, what do we mean by bus tracking optimization? So suppose I am running a fleet which takes Mumbai to Goa. Okay, so I know that I have some people which are being picked up. Okay, all of you are from Mumbai, right? So I know some people are getting picked up from Navi Mumbai, Thane, these locations, and some people are picked up from western suburbs in Mumbai. Okay, and when they come to Vashi, okay, I know that okay, my first bus is only 50% and the second bus is only 40%, but the rest of the route is common, right? So you must have seen like some bus or some like operators, they transfer people from one bus to another and optimize, right? So this is very simple example. This is for people, but this is going to happen for goods. Okay, and the amount of people which move around is negligible in terms of amount of goods which move around. Okay, so when we say bus tracking, it can be a fleet tracking, okay, and optimization, driver behavior and tracking. Okay, so if you look at um, we saw there are so many controllers in the car, right? It can get further integrated in such a way such that when you brake, when you accelerate, okay, when you do anything in the car, all the data is collected in the central location. Now, who will be interested in this? Okay, the insurance companies. If they find this driver, and all this data will be crunched by AI and algorithms, and it will give ranking to the driver behavior saying that okay, this is a careful driver or he's a rash driver and so on, and your insurance might go up or go down. Okay, so if you have tripped any red light, Okay, how it will come to know. Okay, and down the line you will have cameras, and already we have seen e-challans coming in, right? So if you have a car and if you have crossed the line and when it is red, you'll automatically get an e-challan. You have to make sure that you go to their site and check it, right? In India, but in other countries you will actually get it on your mobile intimating you that this has happened. Okay. Then car manufacturers will be interested in like how is their car behaving in the field. Okay, once somebody has taken it. Okay, because they give maintenance, so they want to reduce the cost. Down the line, things will move towards as service. Now, what do we mean by as service? Okay, right now you buy a car, then it is owned by you. Okay, and you can do whatever by it. But suppose you take a car on the rental. Okay, so you can just pay the rent till you use it. Then next day you can take some other car, right? Okay, so when things move towards as service, okay, a lot of things will improve a lot. Why? Okay, if I am a car owner and if you buy the car, right? Okay, my headache of the car is gone, right? But if I am an person who is giving car on rentals, okay, I want to make sure I can make sure the car lasts as long as possible, right? So I'll try to get the best car, right? I'll try to make the best car. So things will start moving towards as service. Okay, self-driving we have seen. Now MG actor, you must have already seen the ads where you can talk to the car. Okay, energy, energy like with smart meters. Last smart meters we talked about, connected grid we talked about, dynamic charging. Okay, so non-peak hours the charge will be less. Okay, so that is dynamic charging. Retail. Okay, retail is like in-store experience. Moment you walk into a store, automatically your facial recognition will be done. Okay, depending on your past history. Okay, you will be guided through the aisles or you will be guided through whatever schemes or whatever advertisements which are there, depending on offers which are there. Okay, targeted offers will be pushed towards you. Okay, then so this will be in-store experience or in-mall experience, but virtual shopping malls will be there. Now, what do you mean by virtual shopping malls? Okay, you can sit at your home and actually do your shopping as if you are in a shopping mall. Okay, with 3D. Okay, so this is going to be the next shopping malls. Okay, cities, buildings. Okay, now these are like smart cities, smart buildings where I think this must have been already covered, right, in IoT, right? Where you have HVACs, fire utilities, parking, healthcare, digital map, traffic, everything is integrated. Okay, so we'll move on to the next slide. Okay, now IoT and connected to healthcare. So in healthcare, what will happen? Okay, connected health report. So if there is an accident which has happened, so immediately, so down the line, everybody will be implanted with chips. So automatically the recognition will happen. Okay, and the health records will be pulled up and they will know what all allergies are there. Okay, what is the past history? Okay, so in the ambulance itself, okay, half the treatment will be done, so they need not wait till they come to the hospital and so on. Okay, implants, pacemakers, vitals. Okay, what are vitals? Vitals are nothing but like your heartbeat, pressure, blood pressure, sugar, all these are like vitals which are generally taken. Okay, so those will be monitored. Remote diagnostics, we saw like it can be a virtual medical bot or in person you can give diagnostic. Remote surgery. Now what is remote surgery? Okay, this is being picked up because of 5G. Okay, a surgeon who is present in another part of the world can operate on a person in another location or guide an actual operation which is happening. Okay, so AI based digital diagnostics like so this is another area where AI will come into picture and say, okay, the person has this, and this. Okay, what are the probabilities of he having or generating this kind of an sickness, or all these things will come up. Okay, or like the DNA sequence is so and so. Okay, what can happen? What is the possibilities? Okay, so these things will come up into come up down the line. So a person, moment a person is born, okay, or a baby is born, okay, immediately everything will be known from the DNA sequence. Okay. Supply chain. So supply chain, like the goods will be monitored, whatever shocks the goods have taken, like if it is something fragile, okay, those can be monitored in real time. JIT we have seen. Pillage is like somebody stealing or it is lost, theft, real time location, route optimization, loading plan. Okay, what is loading plan? Okay, um, now I have, suppose I have an okay, we'll take a simple case of a tempo. Okay, and I want to deliver goods. Okay, so suppose I have taken an Amazon's delivery, whatever that business plan. Okay, and a lot of goods have come to my place. So when I'm going to deliver, I have to load my goods in such a way such that the fragile things are on top. Secondly, based on my route, okay, I have to make sure the places which I will be going first, I should have those things on top, right? Or those things nearby, right? Okay, so this plan optimization, okay, is huge. Now, tampos and all these things are smaller stuff. Now, if you look at a shipping container, which is 40 feet long, okay, and it takes a lot of people's load, different loads from a lot of people, and it has to go to different people, the loading plan becomes important. Okay, now I'm not just talking about loading plan inside the container, but loading plan of the container on the ship, because the ship goes from port to port. Okay, and if you look at some big ships, okay, they have 7 layers on top and 7 layers in the ship. So that is for totally 14 layers of containers. Okay, and those ships are like huge. Okay, the width is huge. So if you make one mistake, okay, and if your container which was supposed to get off on this particular port is down below, okay, you will have to take everything out, then take this container out and then put everything back in. Okay, and hourly charge for an berth for a ship is like roughly around like 1 lakh rupees per hour. Okay, so you lose. So that's why if you look at those operators who pull the containers off the ship, they are paid like a very handsome ransom. They are like people who get paid the most. Okay, and they have to do like around 40 containers per hour, 40 to 50 containers per hour, and they cannot do it just jerk it and do it very fast because the container will start swinging. Okay, so it's a special kill. Now we'll move on to the next one, agriculture and breeding. So here the animals will have implants, it will monitor. Okay, agriculture we saw roughly all the parameters will be monitored. Uh, Robots will be there, it will harvest. Okay, so in the near future you will find that you just give your GPS locations of your mm, field to a tractor or whatever equipment you have and just leave it. Okay, so it's on its own, it will go and plow the field or do whatever it is supposed to do. Okay, so these kinds of intelligence will come into vehicles. Okay, uh, then okay, we should talk storage, cold storage planning, when a particular demand will be there in the market, how long it has to be stored, what will be the cost optimization, all those plannings will be automatically done and it will give a lot of data to end user. Now predictive maintenance. Now we'll move away from preventive maintenance. If you have a car, right, most of us have cars, right? So we have a schedule where it says that okay, after so much time or after so much kilometers or after so much whatever, you have to do this particular maintenance, right? This will move from predictive to preventive to predictive. See, predictive means it will listen to the signals, okay, the sound, vibrations, and all these things which it can capture, and it will tell that okay, this thing can fail. Okay, because you have so these kinds of sounds or these kinds of vibrations. Okay, there is a high probability that the belt might fail or this might fail and so on. So that will really help in the future because suppose you are going for a long drive, okay, like you are going to your native place, you don't want a breakdown, right? Okay, so you generally go for a preventive maintenance, but predictive maintenance will tell you beforehand. Okay, if something is going to break. Okay, then there are links in the bottom where you can see videos for IoT. Okay, so there are different use cases. We'll move on to the next slide. Okay, IoT in warfare. Okay, war will not take place just in battlefields. Okay, so that's a myth. Okay, so if it takes place in battlefields will be integrated. Okay, so assets in the battlefield will be monitored. So now what do we mean by asset? A personnel, okay, a soldier in a battlefield is taken as an asset. Okay, a tank, a missile, everything is taken as an asset. Okay, so deployment of attack assets, tracking, spying, okay, unmanned warfare, all this will be, so IoT will be playing a huge role in this area. Okay, mechanical mules are like these are kinds of robots which can carry a lot of stuff. Okay, autonomous hunt and kill. Okay, now what are these? Okay, you can have like suppose it's an there are different kinds of warfare, jungle warfare, urban warfare. Okay, or like you have to capture cities and so on. So um, urban warfare is very difficult. So in those cases, what will happen is there will be small autonomous robots which will have infrared, which will go around the corners. It will kill stuff. Okay, these kinds of things will happen down the line. Okay, there are already things like it looks like a pipe, like your metal pipe. You just drop it from an like a plane, and it will go and get automatically. It will go inside the ground and stuck there. Okay, it will start sensing whatever is there in that particular area. It will have an image recognition feature, and you can program it in such a way such that if a car with a particular number comes in, okay, into that vicinity, okay, it will automatically uh, pull up a missile from the pipe and it will shoot it at that car. Okay, so such kinds of things are already present. Okay, so you don't have to have like people running around shooting people and so on. So things will change in integrated battlefield a lot. Okay, warfare in non-battlefield areas like flooding network with bot attacks. Okay, now attacks on critical grids like electricity, water supply, financial grids, attack on healthcare. Now all this is IoT related because here you have devices and you will attack those devices. Okay, sabotage key installations. Okay, now I'll give you an example. Okay, Iran was working on nuclear enrichment, right? Which you must have heard right earlier. And for that, you need a centrifuge, which will enrich uranium. So these centrifuge work on a particular protocol, and those were very isolated in a particular location. Now, people wanted to sabotage this plan, right? Like they did not want Iran to have nuclear stuff, right? So how did they do it? So what they did was they had CDs with malicious software written onto it, and it was thrown in multiple places, and such that employees working there can pick them up, and if they just insert it in their workplace, okay, that particular malicious software was able to connect from the Ethernet network, go on to the network where these devices were connected, not just on Ethernet, on the CAN, okay, CAN protocol, and they made those centrifuges go out of control in the centrifuge cycle. Okay, so if your washing machine is running at some RPM, and if you just increase the RPM, okay, you know what happens, right? Okay, so these kinds of attacks happen. Okay, so we'll move on to the next slide. Okay, it's 254, right? Okay, now you have different sensors, right? So 5 senses we must have seen, right? Like smell, vision, touch. So taste is not important. In some cases, taste is also taken care of, but you have these things, okay? For vision, it will play a major role. So you will have a lot of AI related solutions which will work in image processing. So you can look at some softwares which I have written. So you can take some projects in these areas. Okay. Then there are 2 links which I have given for security. So you can take those. Okay. Now let us look at those protocols which are there. Okay. Zigbee, LoRa. So most of this must have been covered, but I think SDR might not have been covered. Okay. So Sigfox, like it will give you 12 bytes. LoRa, it will give you some, I think 38 or something, right? 28 bytes or something max size, right? Um, yes, I think yes. And Zigbee will allow you to do point-to-point communication and those networks. Bluetooth, Wi-Fi, you already know. IR, you know, infrared, right? And Ethernet. So SDR is nothing but software-defined radio. It is nothing but like it can work on VHF or UHF band. Like you have radios, right? So you tune into a particular channel, right? And when you tune, channel is nothing but a particular frequency, and you send your actual signal on that particular frequency. And when you tune it, you get resonance on the other end, and you can listen to that particular music, which music or whatever is being transmitted on the other side, the signal, right? Now SDR is also used in your keys of your car, right? When you press the beeper, right, you open the lock, right? Okay, of your car. So if I just record your SDR, okay, the waves which you are sending, okay, and this can be easily done. There are projects which are available on YouTube where you can have an SDR signal recorder, and if you play it back, I can just so if I just record that, I can just play it and I can take access of your car. Okay, so on the security front, these things are very, very important. Like LoRa, Sigfox, because of their small size, you cannot use RSA keys. Okay, so how do you use bit blockchain and those things to take care of Sigfox or LoRa? Okay, so those we'll see ahead. Okay, moving on to the next slide. Digital assistants. So you know Alexa, right? Google Assistant. You already see ads, right? So these will play a major role. It will not just connect devices. It will ask for external help. If there is fire, it will ask fire department. If there is a medical emergency, so these things will evolve further. Okay. Intelligent bots with NLP. Now NLP is nothing but natural language processing. So you talk naturally, right, with those bots, and you expect them to understand. So when we talk naturally, okay, we have a context between what we said earlier and what I'm going to say next. So these contexts are generally made into tree structure. Okay, so that is NLP. So that's a totally different area altogether. Okay, connected home, internet search. Okay, appliances, digital assistant means you want to make a meeting, you want to keep your calendar, it tells you which meeting is going to come up. Okay, when you have to what is available in the fridge, okay, what you have to buy and all that stuff. Okay, so it will become like a companion to you. Okay, in Japan already there are virtual pets. Now what do you mean by virtual pets? You have a stone. Okay, I mean a stone which is made like a pet, and then you have an app, okay, where you actually have to feed it, you have to do all sorts of cleaning, you have to do, so it like the app will give you blinkers and how you have taken care of the app, of the pet, the virtual pet. Okay, so all that ratings are there. There is uh, you have leaderboards and all that stuff. Okay, so it's like crazy stuff. Okay, so people are going towards those things. Okay, cloud computing will be pay per use model like electricity. The big boys have the compute power, you take them, okay, like you take one instance or multiple instance, so that is infrastructure as a service. Okay, then pass is nothing but, okay, so suppose on the electricity, I want to build some software, right? Or on I want to build some equipment which uses electricity. So you have ICs, right? Ready-made stuff. You don't have to make things from bare bone. So platform as a service provides you blocks, building blocks to build software on this cloud area. Okay, so you have Salesforce, you name it, a lot of them are there. Okay, so you can use these words and look up saying, okay, what are these? Okay, software as a service. Software as a service means you write the same one software and you give it to multiple companies. Okay, not as separate copies. You host it and they will come in as, okay. So software is like suppose abc.com. So suppose I sold it to company A. So a.abc.com will log in, or shineanchor.abc.com. Then I suppose I give it to vjti.abc.com. So when they log in, they see as if it is there. So everything is same. Means everything is personalized, look and feel, but under the hood, things are same. Okay, so that is software as a service, storage as a service. So if you look at storage, okay, like way back in 97 when I brought an hard disk for, okay, you will be laughing. Okay, it will be 4 gigabyte. Okay, 4 GB hard disk, which was the latest hard disk, and it was a bigger size. Okay, it's this big, and that costed me 11,000 rupees. Okay, now the storage is in peanuts. Okay, like it costs you peanuts, like it costs you cents, like if you do you use something from the cloud. Okay, so even your Gmail account, okay, you have unlimited mail space, right? Okay, so we'll move on to the next one. So you can go in cloud computing in detail. Big data. Okay, what is big data? Okay, if you look at big data, is nothing. IoT is like small creeks and rivers feed data into the big ocean of big data. Okay, now why do we need big data? Okay, because you have to crunch that amount of data to bring out information and take it to a level where using AI or machine or any modeling to a wisdom level where you can take some intelligent action, okay, beforehand, right? So you know that these things are happening and it will go down the line to this thing because my past data is telling me that. Okay, so those things will happen. Okay, so IoT will pump in lot of stuff. Okay, so big data will be huge. Okay, and it will be used in all sorts of areas, like right from fleet tracking, remote health monitoring, you name it. Okay, so there will be a lot of tools and people will be using big data in the IoT area. We'll move on to the next slide. Okay, it's 3.2, right? Okay. Blockchain. Now, what is blockchain? It is a distributed ledger, right? So if it is a database, you make change in the database and it is golden, right? But if it's a distributed ledger, you don't know where all the distributed ledger is present. So you cannot go and tamper it. So it's like pattar ki lakir. So if you make it once, it is there. Okay. So your transaction or whatever it is written means it is written. So how does it play a role here in IoT?
Yes.
Yeah.
Sorry to interrupt. So we have a next schedule at 3:30. So
Yeah.
it's a humble request to finish the session on time, sir.
3:30, right?
Yeah, 3:30, sir.
Yeah, yeah. We have, I think it's 3.2 right now.
Yes, sir.
Yeah, yeah. We will. I'll finish
So
it.
we
Okay.
have Q&A also,
Yeah, yeah.
questionnaire.
I'll take questioning also.
Yeah,
Okay. Right.
yeah.
So blockchain will help to combat security because you will be having hub and spoke, okay, models, and blockchain will play a major role there. Okay, so it will help in supply chain logistics. So you don't have to take the data right to the central location. So you can make hub and spokes with blockchain. Okay, move on to the next slide. AI. So AI we have seen, right? AI, all that data which is coming in. Okay, has to have some AI. So we need some information. So IoT device will be the nervous system and AI will be the brain. Okay. So if you look at smart retail, it will have facial recognition, building automation will have automatic temperature adjustment based on the number of people inside, lightning adjustment, predictive maintenance based on past data. So all this will play AI will play a major role with IoT. Okay. So IoT and AI will go hand in hand. Okay. We'll move on to the next one. Digital twin. Okay. Now what is digital twin? Sorry. Okay, digital twin is nothing but a virtual replica of a physical device or a system. Now, why it is required? See, suppose it's an heart. It has all the parameters of the heart and everything of a person's heart. So all the blockages, all the rate at which all the blood is pumping in different arteries and veins of the heart and so on. Okay. Now, if a doctor has to take an intelligent decision, okay, one is he can directly do it on the live heart. Second is he can have a digital model of that heart, and then he can try different sorts of things and see what happens. Right. So now to bring out a digital twin, you should have a lot of earlier data. So if you do this, this happens. If you do that, this happens, and so on and so forth. Right. So digital twin will be playing a major role. Now, oil rigs. Okay. So oil rig, sir, there are a lot of different kinds of pressures. Okay. So if the pressure mismatches, okay, the oil rig can blow out, which is dangerous because it can kill people. Okay, so there they have digital twin created of the oil rig. So it will immediately tell, okay, this thing has happened. What is the best approach? Okay, mid-flight engine warning lights up. So the digital twin will actually work on it and it will tell, okay, this is the best approach. Okay, fly by wire stealth bombers. Now you must have seen bombers have to take heavy loads, but at the same and that's why they cannot move at a very high speed. But they have to have a camouflage or they should not be detected on the radar. So their shape is such unique. They the laws of aerodynamics are thrown out of the window. Okay, so it is very difficult for a pilot to manually fly the plane. So it is flown by wire, means everything is done through avionics. Okay, so it is electronics which is sitting inside the plane, which takes care of the bomber to make sure it flies properly. Okay, autonomous vehicle, driverless cars. So that is going to come. Okay, farm tractors. Okay, warehouse robots. So now, if you look at Amazon warehouses, those are huge. Okay, without lights, and there are robots moving around left, right, and center, bringing out goods to the window. Okay, based on the whatever records which are punched in. Okay, driverless Uber right now you have a driver, right? Then down the line you will have Uber which will be driverless. Okay, the cars automatically, the cars will be coming to your locations. You will see no drivers in it. Okay, you'll sit in it and it will take you to a location. Flying pods, delivery drones, all these are here to stay. Okay, we'll go on to the next one. 3D printing. Okay, so IoT device has to go in different places. Okay, in custom shapes and sizes. So 3D printing will be used. So if 50 billion devices are going to come in, so you can think of how much demand will be there for 3D printing. Okay, so already there are chocolates printed, there are things printed. House is printed. Okay, full house. Okay, is printed using a 3D printer. So who knows, like down the line, you might have you order something online and it gets printed in your 3D printer at your home. Okay, so we'll move on to the next one. Robotics and automation. So with AI and ML models, okay, robotics will enter into a new age where robots will take over most of the jobs. Okay, and automation will play a major role with feedback loops. Now, what is feedback loops? Like if you take an action, okay, there will be a feedback given to it so that it starts improving. So suppose if you are moving a thing, so it tells you how much it is moved and at the same time, so it improves your accuracy. Okay, so these feedback loops will play a major role, and with human emotion, okay, coming into picture, okay, AI and robots will start behaving like humans. Okay, we'll move on to the next one. AR, VR, okay, augmented reality. Augmented, we saw that an existing thing is there. On top of that, something digital thing is superimposed. Okay, it will be used for repairs, guided maintenance, training. Okay, it will tell you what to open, how to open, which tool to pick, and so on. Remote guidance. Okay, if somebody sitting in the main office can guide an person who is actually on the field. Okay, through VR. Okay, so both of them are on the same VR session and they are guiding each other. Okay, virtual reality. Okay, so virtual reality is nothing but suppose for an oil well drilling. Okay, so they have an 3D image of the whole terrain as well as what is under the terrain. Okay, so you will see multiple of these geologists in one room. Okay, there is nothing in that room. All of them are wearing 3D glasses and they are looking into the space and discussing something like the pipeline should go like this, and they are waving their hands in air and showing like this, and each one of them is understanding. Okay, so they are actually working on a virtual reality where they are looking at the 3D models from different angle and they are doing things. Okay, and deciding what is the best way to drill. Okay, now 3D model of a car, which will before the car is created, the model will be created and everything will be designed in it, and people will be discussing on that. Interior design, virtual conferences. Okay, so games, training, virtual exhibitions. So exhibitions are like you go to an exhibition, right? You go to an counter and you discuss things, right? Same thing will happen, but you can do virtually and you will feel like you are actually in an exhibition. Okay, so real-time data connectivity will be there with the backend to get all the necessary data. Okay, it's not just superimposing an image, but also to get that data. Okay, so you will be able to learn like how to assemble or disassemble an airplane engine. Okay, airplane engine. Okay, sitting at your home with an virtual tutor and doing practical in your VR. Okay, so actually whatever actions you are taking, It will be seen by your virtual tutor. Okay, and it will guide you also. Okay, so you can do your real life practical. Okay, way forward. Okay, embrace the change, adapt and move ahead because there is no other way. Okay, resistance is futile because business and economy drivers are correctly paced, because you must have seen if business and economy drivers are there, okay, the change is driven. Okay, pick up new technologies, adapt to new ways of life. Okay, so we'll move on to the next slide. Okay, and impact. Upcoming next 10 years are very crucial. Okay, why? Social, environmental, economical changes are evident. Okay, what is relevant now may not be relevant down the line, as most of them are disruptive implementations. So if the implementation is add-on, it's good, but if it is disruptive, a lot of things will be shaken up. Okay, and things will change. We'll move on to the next slide. If you look at EU's approach, okay, this is like what they talk about. AI should be trustful, digital solutions should be there, and so on. So you can read on this. Okay, so AI, so EU already knows. Okay, what can be the impact? Okay, so we'll move on to the next. EU is nothing but European Union. Okay, long-term impact. Digital privacy will be a myth. Okay, your life will no longer be private. It will always leave digital footprints. Whatever you do, whether you do a transaction or whether you buy anything or whether you move one place to another, your location will be tracked from your device and so on. Okay, person existence will be dictated by digital existence. Okay, so a person digital existence will override a person's existence. Okay, so with so many devices on wireless, like on 5G, 6G, there will be heavy dosage of wireless. Okay, it will be like living in an kitchen microwave. Okay, so this is going to be there. Okay, so impact on health is not studied in that length at for a longer duration because these are technologies which have come recently. Okay, uh, with most of the jobs picked by automation and robots, life will be totally different. Okay, we'll move on to the next slide. Long-term impacts. Okay, warfare will happen on digital front and biological front. Why biological front? You want the assets. Assets means whatever is present in that country, but you don't want the people there, right? You want to cripple the country, right? So you will attack on digital front. If you go and bomb a city, the city is destroyed. If you go and bomb a natural resource, it's destroyed, right? So when now the warfare will be totally changing. Okay, most of the crimes committed will be digital. Human will have an active presence in the digital world than in physical world. Okay, room to room WhatsApp chats or these things will be sent. Okay, instead of like with robots acting like humanoid, who knows, laws might be passed where people will choose humanoid as life partners. Okay, it's not all gloomy as better sense will prevail. Okay, so thank you. So I think I completed. Okay, it's 3:14, right? So we can open up for question and answers.
Thank you so much. We'll
Yeah,
start with the first question.
yeah.
What are the countermeasures to avoid, detect, and counter attack, act or minimize the security risk?
Hmm. Okay, this is a general question. Like when you look at security risk, okay, so you have to look at multiple areas. Okay, so suppose if it is a data center, okay, it can be a person walking in your data center and taking an hard disk away, or it can be a bot, which or it can be a malware which is getting injected into your software, okay, and which is stealing, or it can be an SQL injection which is happening in your application, or a cross-site script which is happening in your application, or it can be a man in the middle attack which is happening on the network, which is nothing related to your application but because of your network security. So if you look from a security point of view, there are layers which I talked about. onion layers. Okay, so security itself is an major area. Okay, can you go back to my IoT slide? Okay, can you go back? Okay, there are two links which I have pasted for security. I'll tell you. Okay, that will give you more insights. Okay, go back, further, further. That's it. Okay, go to the next slide. Okay, see IoT Okay, so this is an foundation which is built only for IoT. Okay, so here you will get a lot of material. They will talk about in depth. Okay, about security. Next is an OAPS. OAPS is actually for an web application protocol. Okay, open standard web application protocol security. So here they also have a section for IoT. So how you have to write application, how you have to deploy application. When I talked about human, because I told you about the man and the dog, right? Okay, so it is the humans who create problems. Okay, either it is an hacker or somebody with a malicious intent. Okay, who can just physically walk in and do something. Okay, so you have to have onion layers on different layers. So you have 7 layers, right? When you talk about TCP, right? So here you have not 7 layers, you have multiple layers. Okay, depending on how it is deployed. And with devices, things change a lot because suppose I am using Sigfox, I cannot use RSA. Okay, so I don't want device to come and hook up into my network. It is I who will means the application has to initiate and go and connect the device. And we will make sure that the device's network is separate. It is isolated with a gateway. OK, we will make sure that if a device gets compromised, OK, how can we detect and so on. So there are a lot of guidelines. Security in itself is a major area. So I think there was a session already, right? So I did not cover too much in security. I just put in the links. Okay, these links will give you some idea, and whatever I answered, right, with that onion layer. Okay, you have to look security from that layer. Okay, I hope the answer is clear, right?
Yes, sir. There is another question.
Yeah.
Uh, how to detect if the IoT device or compromised as far as security is concerned?
Okay. Now see, if you look at devices, you you will have data coming in, right? If it is a sensor or if it is an actuator, you will have that device doing something else other than what you want. Okay, so the best way to make sure is you want to make sure the signatures which are generated, the hashing algorithms which are generated, you can match them. Okay, now hash is one way. At the same time, if you have a digital ID to it, you can detect that. Secondly, you have to make sure that nobody can tamper it. Okay, like if you saw the POS terminal, right? So POS terminal will actually take your credit card information and it will send it to either Visa or MasterCard, right? They want to make sure that it has come from the credit card. It's not coming from some other place, right? See, they don't know it is coming from a POS, but they want to make sure it is coming from the POS. So they will have some identification in the POS such that it is not transferred. So when you build devices where you want to make sure that it is custom built, okay, you will have 3D printing to build it. At this, why do you have 3D printing? You will custom devise your device, okay, the electronics inside, and then on top of that you will do 3D printing such that nobody will know what is inside. See, you must have heard about Dambarka Goli circuits, okay, or COB circuits. If you open any toy, you will see an PCB with nothing but one a drop of gel on top, right? It will look like an you will not know what is the IC being used. Okay, so a lot of devices will be built like that. So you will never figure out what is there. Secondly, inside there will be IDs which will be pumped in. But now with LoRa, Sigfox, and their limitations of bandwidth sizes, okay, and like one says only 12 bytes you can transfer, other says only 28 bytes you can transfer max, right? Payload. Okay, so things will start changing. Okay, there will be other protocols which will come up a moment the bandwidth improves a lot. Okay, so if it is compromised, you will see abnormal data coming in, and you have to have different layers of security which will throw alerts. So if it is a DOS attack, it will say that suddenly I have a lot of abnormal data coming in. Is it compromised and so on? Okay. So there, if you have to go in these links. So preventive measures are the best measures. Once it is compromised, finding it is very difficult, because if I am a smart hacker, I'll make sure you never find out. Okay. I hope the answer is clear, right? Yeah.
Yeah, thank you so much, sir. Thank you so much, sir, for taking today's session by enlightening with your knowledge in the IoT application. And sir, thank you so much for taking us through various fields how the IoT applications are applicable. Like IoT by itself is integrated to how many different fields and area. You have enlightened us to the cloud computing, the big data, and actually you have taken us to the even the IoT devices as well as the sensors, the actuator, how do they work and they respond to the different IoT applications. Sir, your session itself was showing you your years of experience that you have went through these technologies and devices you are handling, and helping us to know the role of the IoT in the various applications, especially in the today's age, wherein everything is being converted into digital. So IoT, I think it helps us a lot for integrating this digital world without any human interference. And sir, you have all taken us with even previous experience, also age experience. You have taken us how we are landing up into the digital by taking small examples. That was very much enlightening us, sir. Explaining us very nicely. Thank you so much, sir, for such a wonderful session. Um, I take this opportunity to uh, felicitate you with this small token of appreciation. Sir,
Thank you.
please accept.
Yeah, thanks a lot. And sorry to all the folks, because I was a bit fast, because I tried to condense a lot of information in whatever time I had, so that at least you know those topics. You can take this PPT ahead and then you can search on the net and you can explore further things. Okay, so my aim was to view all the things which we have till now seen, okay, or heard. So that was my aim. So sorry if I was a bit fast. Okay, so my aim was to
No,
finish on
sir,
time.
you have covered up almost all the areas actually.
Yeah,
Thank you so much, sir.
yeah,
Please accept this small token of
yeah.
appreciation.
Thanks a lot, and it was a great pleasure. Like,
Thank you so much.
thank you.
For all the participants, the feedback link and the attendance link will be posted in the Q&A session. You can give the feedback and attendance.
So I think we are on time, right? Okay, yeah, great.
Yes, exactly. Thank you so much, sir.
Thank you. Yeah, take care, everybody. So I think I can leave, right? Yeah. Thanks a lot, everybody.
Yes.
Yeah, yeah. Bye bye. You can set the meeting for next participant.